All right, this is 1994 M1. This is Horner, and this is for AP Physics C. We've got a ball of clay which is moving with a velocity. It runs into 0.1 kilogram. It runs into this 2 kilogram block, which then compresses the spring. And then we've got another block here, which is 8 kilogram, and it is held still by a removable stop. And so there is a compression here. In an initial experiment, this 100 gram or 0.1 kilogram ball is thrown at the block. The clay is moving horizontal with that speed v. The 8 kilogram block is sitting there, and the spring compresses a distance here of 0.4 meters. So that'll be pretty important to know. So we're going to compress this 0.4 meters. So that will be the change in the stretch or the compression. So they want us to figure out what is the energy stored in the compression. And so we know that the potential energy of a spring is equal to 1/2 of kx squared. And so now what we'll do is we'll do 1/2. The k value is 200. We see that here. And they also mention it right here. And then our compression is 0.4 meters, and that is squared. So when you do your math, you should end up with 16 joules of energy. So really easy part of the problem. It says calculate the speed of the clay ball and the 2 kilogram block immediately after clay sticks to the block before the spring compresses significantly. So we're going to use conservation of energy here. We're going to say 1/2 of the mass times the velocity of that ball squared is equal to the potential energy. So we're going to find out what that potential, we already know what that potential energy is because we just solved for it. And so we want to find out what is the speed of the clay and that block immediately afterwards. So at this point we're going to say the velocity is equal to the square root of 2 times the potential energy divided by that total mass. So big M here is total mass, so that'd be the 2.2 kilogram block plus the 0.1 kilogram ball. So this mass is going to be the 2 kilogram block plus that 0.1 kilogram ball. So we're going to put MT here. So this is equal to, and then we're going to take 2 times that 16 that we determined earlier, and we divide that by the 2.1 kilograms. So your answer is now 3.9 meters per second. Okay, great. Now that we know the final speed of both the clay and the ball when they're stuck together, we can go back and find that unknown speed of the clay. So how are we going to do that? We're going to use conservation of momentum. So what we'll do is we're going to say m of the ball times the velocity of the ball plus the mass of the of that block. Okay, so when we go back up, you'll notice that that is that 2 kilogram block. So this is going to be the block. You know what? Let's go back and let's change these B's and let's make them C's for clay. So this is the mass of the clay times the velocity of the clay plus the mass of the ball times the velocity of the ball. And that should be equal to the total mass times the final velocity of both things, which we already know. This was 0 to begin with. So now we can say that the velocity of the clay should be equal to the total mass times the velocity of the two things divided by the mass of the clay. Total mass was 2.1. We know the final speed was 3.9, so we need to divide that by 0.1 kilograms, and we end up with 81.9 meters per second. So we know it's got to be a pretty big speed since it doesn't have much mass, and it's making both it and that 2 kilogram block move at a speed of 3.9 meters per second. Let's go ahead and take a look at the second experiment. It says in the second experiment an identical ball of clay is thrown at another identical 2 kilogram block, but this time the stop is removed so that that 8 kilogram block is free to move. So we're making it more difficult. They want to know, is that maximum compression of the spring greater than, equal to, or less than the 0.4 meters? So it should be less than the 0.4 meters. And your explanation needs to just have something that refers to the motion of the blocks or their kinetic energy. So you could say something like the 0.8 kilogram block will begin to move before the spring can compress as much due to the force that the spring it exerts on it. You could also say that that kinetic energy of the center of mass of the system in the case is non-zero, or some of that energy must remain as kinetic energy. Less energy is available for the potential energy, and so that compression is less. And so what I'll do is I will go in here and we'll just paste that in so that you've got it. And that would give you the 2 points for part D. Let's go ahead and look at part E. For part E, they want us to state a principle that can be used to calculate the velocity of the 8 kilogram block at the instant that the spring regains its original length, and then write an appropriate equation to show those numerical substitutions, but don't solve for the velocity. Okay, so we're not going to solve for the velocity in the end. Let's go ahead and let's give our conservation momentum. So here we go. We've got the total mass times that original velocity should be equal to the total mass times the velocity afterwards. And then we want to add to that m2 times the velocity of the other object. So at this point, and 2 and 3 represent those two things. So let's go ahead and plug everything in. We know that we've got to substitute some things in here. First thing is we're going to take 2.1 times 3.9. So 2.1 was the mass of the ball and that original 2 kilogram block. This is the velocity, and that's going to be equal to 2.1, okay, times the velocity of our object that we had here. So that's clay and the ball, the clay ball and that first block, plus, and then this is the 8 kilogram block times its final velocity. We know that conservation of energy is applicable here, so we're going to say 1/2 of the mass times the velocity squared should be equal to 1/2 of the mass of the original objects times their velocity squared plus 1/2 of mass 2. And remember, we said mass 2 is of that 8 kilogram block times its velocity squared. So now we're going to substitute in. We're going to do 1/2 of 2.1 times 3.9. We're going to square that, and that's equal to 1/2 of 2.1 kilograms, because that is the mass of the clay ball plus that 2 kilogram block, times those, the velocity of those two things together squared, plus 1/2 of the 8 kilogram block times its velocity squared. And so now at this point we should be good, and that should be everything that you need in order to solve this problem. And so we are finished with it.